Hey everybody, and welcome back to Radical Slice, where we try to mimic some classic gaming mechanics and knock together a barely playable demo. This time, we're trying to make something like a dungeon from the original Legend of Zelda on the NES. In the last episode, we set up our player and added some movement and got a baddie in there, added collision, and finally we put together an event queue to handle our collision events. This time out, we're going to pick up by giving that baddie some kind of random AI. So let's rock and roll. I'm actually not sure how to go about doing the AI routine. So I'm going to try to work this out in Paint. When in doubt, draw some heckin' diagrams, am I right? So I'm going to try to think of this like a state machine to represent our baddie's behavior. So we'll draw a box, and the baddie's going to start in some sort of like initial state. Let's see if we can write properly. So we'll just call this initial or init. And we don't want our baddie to attack necessarily. I think he's just going to walk around, maybe stop and pause for a few frames, change direction, walk some more. So kind of at each point, at each decision point, he'll either walk some distance or pause for some time, right? And when I say walk for some distance, of course, he could potentially change direction in that. So let's get a few states here. So we've got our initial state. We're also going to have a wait state and a walk state. Call this wait. Call this walk. Okay. And so from that initial state, like when the game first boots up, he'll either wait or he'll pick a direction and walk. And then from either of these two states, whenever there's another decision point, he could change. He could repeat the same thing, or he could sort of change his behavior, right? So effectively after that initial decision, it's going to be just wait for some time and then walk and then wait or walk. It's kind of like either one, right? So there could be a series of walk events in a row. It could be a series of wait events in a row. Hopefully not too many wait events in a row. That'd be kind of weird. Maybe we'll write some code to prevent that. But anyway, like wait for some frames and then walk for some frames. So I have to have some sort of control, some sort of like counter to control when the baddie will then update its state. So let's kind of get to coding. I think it's probably easier to just like start coding this thing out and see how it goes. Go back to the terminal. Okay, and we're going to pop into the baddie tab here. There it is. All right, great. So we need an update function. I think we defined one of these for the player, right? We did not. We did not define an update function for the player, but we're going to do one for the baddie first. So this is something that's going to run every frame. And I think in order to represent our state machine, the baddie's going to need a state variable. And his initial state is going to be init, like we said from that diagram. And we'll also have some sort of, we'll call it a TTL, which is generally an abbreviation for time to live. This is kind of like the counter that we'll use to count down. Every time the baddie makes a decision, we'll add some value to the TTL counter. We'll count it down. When it goes to 0, we'll have him reevaluate his behavior and optionally change from walking to waiting or vice versa. Okay, so we'll initialize this to 0 because we want him to make a decision right away when he first boots up. So in the baddie update, if TTL equals 0, then make a decision. And possibly change state. So let's see, how do we want to do this? You can choose to either wait or walk. Now I think like walking is more interesting. We want walking to happen more often than waiting. Waiting is like kind of weird and it shouldn't happen all that often. So let's say, for example, every time we have to make a decision with some probability, let's say 75% or 80%, say 80%. With 80% probability, the baddie will elect to walk in some direction. So we're going to use Pico-8's rand function. And that's going to give us a value, a random value between 0 and 1. And this is good for our ability to make this initial decision. So if rand is greater than 0.2, and so we said like, then do something else, do something else. If rand is greater than 0.2, that means 80% of these random decisions will fall into this first clause. Right, this will be 80% of the time. And in this case, we said we want them to walk. So we'll change the state. That state equals walk. And we'll give them a TTL. And let's say, we also kind of want to randomize the TTL, right? Let me explain briefly what this is. When you call rand, you can pass in a number to be your upper bound. So Pico-8 will generate some random number in between 0 and the number you pass it, in which case, or sorry, in this case is 120. Now we said we want 30 frames and 150 frames. Well, we can't do like a range, right? We can't pass 30 and 150 into rand to get a number between those two numbers. We can only pass in one number as our upper bound. So what we're going to do is cheat. Right? So this gives us a number between 0 and 120. We want a minimum of 30 and a max of 150. So we'll just add 30 to the result of that. And we're going to take the ceiling just to give us an integer because we want to assign this to our TTL. Okay, so this will allow us to add something to the baddie's timer that will eventually count down. And we forgot to add the countdown up here, so we'll do baddie.ttl minus equal 1 up here to make sure that we're always counting down. And actually, since we started at 0 and we're subtracting 1, we want to make sure if TTL is less than or equal to 0, not just 0. Otherwise, that'll never, this condition will never be true. Okay, the other thing we haven't done yet is, all right, we have to give him some sort of velocity. Otherwise, he's not going to move at all. So we'll go back up to our baddie attribute here, or our baddie table, and we'll give him some velocity, which I'll just call like dx and dy. Dx and dy is 1 and 1. By default, he's standing there, so we'll do dx dy 0. We need to give our baddie a direction to walk in. And since we know there are 4 directions, and we value those from 0 through 3, we go back here, we can check that, right? We'll use rand again. And for this one, we don't really care which direction they're going to walk in. Any direction for now is valid, even if that's going to take him off the screen. So we're going to set an upper bound of 4, and then we're going to floor that. And that'll give us an integer between 0 and 3. If baddie.direction equals, and we call this one button up, then we'll say baddie.tx, up will have 0 x velocity, and y will have a -1. We want it to move upwards, so it's a negative y velocity. Now I'm going to go ahead and do the other 4 directions. Okay, I think I've set the velocities appropriately. Now, we haven't done the wait state yet, right? We set up the walk state, but the other 20% of the time, we want the baddie to just wait. So we'll set this up here. And I think we want this to last less time than the walk state. So let's say between 15 and 30 frames, right? Hey y'all, Eric from the future here. As I was editing this video, I realized that I never completely implemented the baddie's wait state. So what should have happened somewhere around here is that I should have set the baddie's dx and dy values to be 0, which would stop the baddie, which is kind of the intention of the wait state. Because I never did that, you will never see the baddie actually stop. He will just always be walking around in some direction or another. That is a mistake. However, I have committed the correct wait state to the repository. So if you want to get the correct code, I mean, it's only 2 lines. You can just copy what's on the screen right now, and that would be sufficient. But if you are to clone the repository, you will have the correct waiting state. That is all from the future. Thank you. Okay. And we need to make sure that we're calling baddie update in our main function, which we are. Let's load this up and see what happens. Oh, we've got one mistake up here. That baddie.ttl, not regular TTL. All right, let's see what happens when we load main. And run it. Nothing. He doesn't move at all. Oh, but he changed direction. That's good. Why isn't he moving? Time to debug. Right. Oh, that was pretty easy to debug. So even though I'm setting the velocity, I'm not actually updating its position. So let's see baddie.x plus equals baddie.dx and baddie.y plus equals baddie.dy. Okay, great. Hopefully that fixes the problem. Run it. Oh, there he goes. Oh, mercy. Okay, up, down. That's good. Oh, he's off the screen. He's definitely off the screen. He may never come back. Okay. Let's start the baddie in a different location so that he's less likely to walk immediately off the screen. However, I will say that did look pretty good in terms of the AI routine. There we go. There he goes. Okay. Oh, good. He just walked right off the screen. Okay. Yep. Not coming back. Okay. Let's set a lower velocity so that he'll move more slowly and we'll have more time to witness what the heck is going on here. Okay, so I've set a local variable here and I've just set it to 0.1. Okay, let's load this again and see what happens. Okay. Oh, okay. Okay, this is vaguely, this is some kind of behavior we're seeing here. I think we can consider this good. I haven't seen him turn right yet. I would like to see him turn right, and then I'll be satisfied with this. There he is. Okay, so we've seen all 4 cardinal directions. I think this is probably fine for like a random AI thing. Now, as we noticed, currently there's no barriers on this in this room. We didn't set up any walls or anything, so we should do that next. So the first thing I think I want to do is just make some quick background tiles so that we can put them on the map and our player and our baddie can, look like they're not just floating around in space. And I think that will do it. Let's load it up. Cool. Okay, yeah, obviously they're not actually in the box and they're not colliding with it, but that's okay. We can work with that. So we need to do a couple things. We need to set the player's initial position differently. We need to set the baddie's initial position differently, and then we need to set collision for both of them with those barriers. So let's go in that order. We want the player now to not start at 0, 0, but let's start them at, let's say, 16 and 24. Let's see what that looks like. Cool. And then we'll start the baddie at the same y coordinate, but further out on the x. So maybe like, I don't know, 64 something. Also probably the same. Maybe a little bit closer then. Let's do 56 for this. What do we say for y? 24? Okay, let's see how that looks. All right, great. Perfect. So they're both going to start in there. Actually, let me reduce the X value here to 48 so we get that nice symmetry. Fantastic. Okay, so now they're both in the box. Now, right now our game doesn't know that our two little characters are supposed to collide with those blue barriers that we made. We have to find out a way to do that. Now in Pico-8, there's a number of ways you can do this, but in Pico-8, you'll notice these little circles on the bottom, and these are for setting flags. They don't have any intrinsic meaning to them. Right? We can turn them on and off like this, but that doesn't actually do anything. It's just a way for us to indicate that they have some property that we're going to define in our code later. Now, the ones that we care about, the tile, we're not going to change, but we do want to set some sort of property for our barrier tiles. So let's just use our first flag. And we're going to set it on for all of these tiles. We probably don't need to do the corners, but just in case. Okay, great. Now, the tricky part. Oh, let's make one quick refactor. I'm going to make a player.update function too, just like we had the baddie.update function here. And that's just to pull this input code out of main and put it in with the player. And then, of course, we need to call player.update here. All right, let's reload to make sure that everything's working the way we expect it. Oops. Okay, cool. Player still moves. Everything's good. Let's set some collisions. Let's do the player first. We'll let the baddie kind of roam around as he sees fit. And if the button's pressed, instead of updating the player's X position directly, I'm going to update his velocity. So just like we did with the baddie, let's set dx and dy equals 0 here. And at the beginning of each frame, initially we'll do the same thing. We'll just assume that the player is not moving. And only if the button is pressed will we update the velocity, or will we set a value for the velocity. It's -1. And again, let's set a local velocity, and we'll actually set this to 0.8 just to make it, I don't know, a little less rapid. So left would be negative x velocity. I'm going to go ahead and set the rest of these now. Now that I've set the velocity for all 4 directions, I have to remember to update the player's x and y positions based on those velocities. So player.x plus equal player.dx, player.y plus equal player.dy. Now, that was just a refactor. We shouldn't see any new or different functionality. So I'm just going to load it up and make sure it looks good still. Everything looks good. He's not moving quite as rapidly anymore. So now let's figure out how we want to do the collision. And I want to do that actually before I update the player's position. So if we kind of have a look at the game really quickly. We don't want him to overlap with the wall. Right? If we update the position and then we check for any sort of collision, then he's going to kind of like look like he's spilling out over the top of the wall. So what we want to do is we want to check to see if he's going to hit the wall. And only if he's not going to hit a wall, then we'll update the position. Right, so let's make some changes to the code. The way we want to do this is to imagine that we have updated the player's position with its current velocity. We're not actually going to touch the player. Like right here, we're actually touching the player's x and y position, right? So we're moving the player. Before we do that, though, let's say we have some like imaginary x and y values. We'll call it fake x and fake y. And we'll set both of those to 0 to start. Actually, no, let's set them to the player's initial current position. And actually, we can go ahead and just like, yeah, just for the sake of explanation, let's leave it here. So we're going to imagine that fake x is the player's x. We're going to update it by the current velocity. So dx, fake x and fake y are going to be updated by the player's current dx and dy. And now what we're going to do is check that if we move the player to this position, is there a barrier tile there? And if so, we won't update the player's real position. The way we're going to do that is to use Pico-8's fget function. And this is what's going to give us the value of that flag that we set here, this little red dot, right? So what we can do is get the map tile. You'll see this pattern used a lot in Pico-8. What it is, you're going to call mget to get the map tile at a certain position. In this case, our map tile are these barriers, or wherever the player happens to be standing. And then you'll call fget to get the value of the flag of that tile. The tricky part about mget is that it doesn't use actual coordinates. It's using the tile index. By tile index, what we mean is sort of this layout here. So you'll see those numbers on the bottom. Let me bring this larger. You'll see those numbers on the bottom, the x000 and y000, and how it changes as we update it. This isn't the x and y coordinates like the player or the baddie would move. These are like sort of quantized tile indexes, right? So right now here, this, if the player was here, the player's position would be like 16, 16. But for the map, it's only 1, 1. So we need to sort of translate the player's position into the map tile index. What we're going to do is take the player's imaginary position, fake x and fake y. We're going to divide it by 8 because that'll give us the index to the map. And also we're using sort of this, normally division looks like this, the /. We'll use the backslash because that automatically gives us an integer rather than a decimal value. And here we don't want a decimal, we want an integer. What this is saying is, if we take the player's fake position, right, this imaginary position, if we were going to move the player to this new spot, they would be located on a certain map tile, right? And if that map tile has the first flag set, then we don't want the player to walk there. Remember, we only set the map tile for these barrier tiles. And so those are the ones we care about. So if that flag is set, we're just going to return. We're not going to update the player's position. Otherwise, else we will. Now that should stop the player from walking on any tiles that have that flag set. There is a small issue, and that is that when we take the player's position, we're actually looking at the upper right, like this up here, that pixel that I'll make it red so it stands out. We're actually looking at this upper right coordinate, right? Which means that'll work pretty good if we're moving to the left or moving up. But if we're walking downward or to the right, the calculation is going to be slightly off. So the player will still spill over the wall. We'll make that adjustment in a minute, but right now let's just make sure that our logic is roughly correct. Okay, good. Yeah, you can see now when he bumps into the left wall, he'll stop, probably at the upper wall also stop, and at the lower wall I expect him to spill over right a little bit, and he kind of gets caught on the face there, which is pretty funny considering his face and the barrier are the same color. Oh, okay, so here's an interesting bug. We hit the baddie and respawn, and because our respawn position was hard-coded to 0, 0, our guy sort of spawns outside of the thing, and he can't get back in, right? Because we've now said that he's not allowed to walk on those tiles. So let's update our collision handler code. And what is our initial position here? 16 and 24. We should probably define these as constants somewhere, but just for the sake of speed, we'll set 16, 24. We'll run again, and hopefully when we get hit, cool. Okay, so yeah, that's not great. Also not great. Let's see if we can make a quick fix for that. Normally I wouldn't care, but it is kind of busted looking, so yeah, give me a second here. Okay, so what I've done here is to say that we made a couple of exceptions because we noticed we were having problems with the player walks right and when the player walks down. So I kind of did a bit of a hacky thing where I say if the direction is right, then instead of using the upper left pixel, instead of using that pixel, use that pixel instead. Similarly with down, I said if the player's direction is downward, add y or I'm sorry, add 8 to fake y. So rather than using this pixel, we're going to use this pixel, which aligns more with what we actually want. That should fix our problem. Let's see. Fantastic. 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 So the collision is a little bit janky. Like he doesn't get as close to the wall as I want. So let me just tweak those values. Okay, so I knocked 2 pixels off of each one. Let's see if that makes it a little bit nicer looking. Yeah, that's cool. Yeah, that's cool. All right, I'm pretty happy with that actually. He walks off the edge a little bit when going downward, but we'll chalk it up to perspective. Now we need to do the same thing for our baddie. The problem is our baddie has AI. And so if he hits the wall, he needs to make a decision about what to do. So we can stop him from walking, but that doesn't necessarily make for a good looking baddie experience. Like he could hit the wall and just wait for the TTL to time out, right? So if he's supposed to walk for like 60 frames, let's say at frame 10, he hits the wall. And now it's like, okay, well, now what do you do, right? Because do you wait for the TTL to time out and just stand there and face the wall? No, you want to like change direction, right? So what we'll do is go back to paint. So what we'll do is let's draw a wall here. Okay, here's our wall, right? And so we'll get our guy. And if our guy is walking and he hits the wall, let's say he's walking in this direction and he hits the wall. At this point, what we'll do is we'll just reverse the direction that he's facing. That way we don't have to do any sort of complicated decision about like, oh, do we go up? Do we go down? Do we increment? We'll basically just like take the direction he's walking in, invert it, and have him walk in that direction a little bit more. And actually, what we're going to do here is very similar to the player code. So we're going to just steal this. So for this update, we'll do that. And it's the same map tile, so we still care about this. And we just have to replace all the instances of player with baddie. So now the baddie should stay within the walls, but we need to improve the behavior a little bit. So this is the case where do something else. This is the case where the baddie walks into the wall. And so we need to kind of update the state here to do something that's not what he's doing. Okay, so I think what we want to do here is let's not be too clever. Let's say they've hit the wall. If baddie that direction equals button right, then and we need to do a couple of things here. We need to change the direction and also change the velocity. So real quick, let's just make functions for function walk up, function walk right. This is probably overkill at this point. But just to set the velocities, because we're doing that in a couple places, to make our code a little bit more readable, we're just going to replace these velocity settings with some function calls. Cool. And to make these more generic, I'm going to replace baddie with sprite inside the body of the function. Totally not necessary, but again, just makes me feel better about my code. So if baddie's direction is right, set baddie's direction to the opposite. L, and then we'll have the baddie walk left. Okay, and we're going to go ahead and do the other 3 directions now. Okay, I think that will probably work. Actually, I'm not at all confident that that's going to work, but let's give it a try. See what happens. Oh, no, we've got a problem. Oh, right. We're not setting the velocity to anything that exists. So, and let's speed the baddie up a little bit. Something like 0.5. I feel bad. Actually, that's it with a 3. I feel like slow baddies are like kind of cool for a Zelda-style dungeon game. Let's try that again. Oh, he just walked right over us. Oh, interesting. Okay, so it's kind of working. The pacing isn't changing, interestingly enough. There's some funky behavior here, but I mean, it's colliding with the walls and moving in the opposite direction, which is a positive change, I think. For some reason, the facing is not updating when I want it to, though. Let me see what's going on with that. Oh, I just noticed one typo. I'm doing baddie underscore direction instead of baddie dot direction, so that won't work. Okay, let's load this up. Not at all confident it's going to work, but we'll give it a try. Okay, so far so good. He seems to be bouncing between those two walls and not doing much else. Oh, okay, there we go. We saw some movement there. All right, great. I mean, I'm going to say that's passable. Yeah, I mean, they're moving around inside the box. They collide with the walls. I think this is good. All right, so I think the next thing we're going to need to add is probably some sort of combat, because right now, the baddie can definitely kill the player, but the player, sadly, cannot kill the baddie. So we need to get that weapon thing functioning. Hey, thanks for checking out the video. I really appreciate you giving me your time. And I hope you found some of the stuff in here helpful and that as a result, you're an even more excellent developer than when you started. If you did find any of this stuff helpful, I should say I've got a lot more of this content coming. So if you're feeling particularly generous, please give me a subscription. But either way, stay tuned and thanks again.